All right, we're back. We're on page 3, notes 15. We're doing integrals by trig substitution. It's when you have a weird radical and you're not really sure what to do. You draw a triangle that could have that radical as one of its sides, maybe the hypotenuse, maybe a leg. And let's see. So there's 4 problems on this page. I don't know. I might try to do all 4. We'll see. So I see the weird radical, and I'm going to go for it. So I'm going to put 4 here. I'm going to put I'm going to put the x here and the radical here. If I don't like what I get, I'm going to switch it up. All right, so I'm going to say that x is equal to 4 times the sine of theta, right? Because sine of theta is x over 4. I usually just say it in my head and then like solve it, because these are a lot of writing, no matter how you do it. So dx is 4 cosine of theta, d theta. If you forget anything, it'll be to replace dx. That is a very common mistake. In general, I guess, with substitution. Cosine is this over this. Oh, I forgot theta. Cosine is the radical over 4, so let's say that the radical is equal to 4 cosine of theta. And then, all right, so I'm just gonna do it down here, I guess. So I don't want to highlight everything throughout this entire video, but maybe I will. It just depends. It's like, I don't know, like, you know, we're all working here. We all know what we're doing, but if you're watching this as your first video, go back and watch the other ones. We're making all these substitutions. There we go. So 4 cosine of theta d theta. I got to square that, so I'm just going to do 16 sine squared of theta. So I'm getting cosecant squared again, and I don't really like that, but I also really don't want to redraw the triangle. So just going to go with it, cancel some things. So I have 1/16 cosecant, the integral of cosecant squared of theta d theta, because 1 over sine squared is cosecant squared. So this will be negative 1/16 cotan of theta plus c. We go to our triangle. So tangent is this over this, so cotangent is radical over x. So negative 1. What am I doing? Negative radical 16 minus x squared over x plus c. I think that's right. I don't know. I'll check them at the end, I guess. Although this problem I noticed looks almost identical to this problem, so like we'll probably be able to just check them against each other. Maybe I'll try to remember to switch the sides on that one when we get there, but maybe I won't remember. Ah, so close. It's like, how bad can it be? And still recognize that I'm trying to make a right triangle. All right, that's got to be x. So I'm going to put 2 here, and I'm going to put the radical here. And we'll see. Like, if we like it, we'll do it. If we don't like it, we'll come up with some other stuff. So secant of theta is going to be x over 2. So x is 2 secant of theta. So dx is going to be 2 secant theta tan theta d theta. That's a long one. I'm not a fan of derivatives that get longer than the original, which means I'm generally not a fan of derivatives, I guess, because almost all derivatives, other than like the power rule where you get a reduced polynomial, it's like you're using the product rule, the quotient rule. So I guess, I mean, I like taking derivatives, so that's just flat out not true, but whatever. Tangent is radical over 2, so 2 tan theta equals the radical. All right, good to go. So let's see, what are we subbing? This for this. We got to do a lot of subbing. This for that, and then one more. This for this. But you get a lot of nice canceling. So let's see. This will be the integral of, so 2 tan theta, and then dx. Do you get a lot of nice canceling? I thought you did, but now I'm second guessing. My insistence upon putting parentheses also makes everything a lot longer, but I do think it's a good idea. 2 secant of theta. Okay, so we got some canceling, like this and this. So we're integrating 2 tan squared. 2 times the integral of tan squared of theta d theta. Should I take a second, pause, regroup, and make sure this is right? Because that seems weird. I mean, tan squared I'm going to turn into 1 plus, to secant squared minus 1 and integrate it that way. But like, does that seem like it should have happened? So so cosine would be 2 over x. So secant is x over 2. So x is definitely 2 secant. If x is 2 secant, dx is definitely 2 secant 10. And then this over this is tangent. So yeah, I guess so. Just like I wasn't anticipating having to do whatever. Everything you learn is important, you know? And so you gotta be flexible. But that's what I do in the middle of a problem. When I run something where I like wasn't really anticipating it, I'll check then because, you know, it's just easier. All right, I mean, that wasn't like the end of the world, but I did complain a little. All right, so I need to replace tangent, but the tangent of theta is this over this. So 2 times the radical over 2 is just the radical. So this will be radical. What is it? Radical x squared minus 4. Minus 2. And then we said that x was 2 secant. So x over 2 is secant. So I'm going to do the inverse secant of x over 2. And I don't think the calculator will give us that as our answer. So what we might end up having to do is take the derivative of our answer. It's often easier to take the derivative of your answer and simplify it than it is to try to like make sense of if yours is equal. Because there's just so many paths it could take. I'm doing all these. I've decided. Okay, so let's go. It's like one way or the other, we're gonna do them, so might as well do them now. 2x, 1 radical 4x squared plus 1. And this is like definitely, you know, you can definitely be doing these on your own if you wanted to. So tangent is 2x. So x is 1/2 tan theta. And then dx is 1/2 secant squared of theta d theta. Okay, and then our radical is secant. 4x squared plus 1 is just secant. It's really the radical over 1 is secant, but like, nah. Substitutions. So this is either going to be really basic integral when we're done, or like what happened. And then dx is this. I'm going to have to integrate secant. That's all right. I have that memorized. So this will be, let's pull out the 1/2. We get secant squared of theta, d theta, over secant of theta, which is 1/2 the integral of secant of theta. I do this weird thing where I frequently forget that they're integrals, and I just like, because it's a lot of substituting. Once you're done substituting, you're just like, yay, I'm done. No, you're not. All right, so the trick for this, if you don't remember it, is to multiply by secant plus tan over secant plus tan, and then do a u substitution. But you will end up with the 1/2 is the 1/2, and then natural log of the absolute value of secant of theta plus tan of theta, and then plus c. A lot of subbing to do. 1/2 natural log of the absolute value. Okay, so we said secant. Did we ever say secant? Secant is just the radical. So radical 4x squared plus 1. Maybe. I mean, I'm pretty sure. And then tangent, we said, is just 2x. So this is actually, I mean, it's not a, you're not looking at this integral and thinking like, oh, I bet it's that. Well, I don't think you are. But I think that's my answer. And I'm going to check, obviously we're going to check it, but like, I don't know, seems good. All right, and now we're going to do this one where I was going to try to switch my sides. So I'm going to have to look at problem number 1 to see. And hopefully you're already done. You're just like skipping ahead on this because this is almost certainly a long video. God, why would anyone want that? Whatever. It's like the key is you can't get too close. If you get too close, then it's not gonna like make your triangle. All right, what did I do last time? Last time I put the radical on the bottom. So I'm gonna put the radical here. And then that means this is x and this is 3 and theta. All right. So then secant is x over 3, so 3 secant theta is x. 3 secant tan is dx. And then the radical is going to be, so tangent is the radical over 3, so 3. All right, substitutions. We got 3 things. We got a radical, going to be that. We got a dx, which is going to be that. And we have a x, which is going to be that. Here we go. Integral dx is 3 secant tan d theta. Oh, I forgot d theta. Ooh. D theta. Perfect. Okay, and then give me a marker. X, so I'm gonna write 9 secant squared. And then the radical is 3 tan. All right, so what cancels? Some stuff like this, that, and then one of the secants. So we end up with something. 1/9 the integral of 1 over secant, which is just cosine d theta. So I'm going to get 1/9 sine of theta plus c, which will be what's sine of theta? Sine of theta is this over this. No, it isn't. Oh my God, I just got sine of theta wrong. Sine of theta is this over this. So I'm going to get the radical, which was radical something, x squared minus 9 over 9x, I think. How does that compare to the previous answer? All right, the previous one had a negative in it. So should this one have a negative in it? Or is there some, I do not personally feel like there's something inherently different that would have given one a negative and the other one not a negative. So was there a mistake? Were mistakes made? I'm not really sure. I mean, nothing involved here would have a negative with it. So then on the other one, should I have had multiple negatives that I like messed up somewhere? Derivative sine, that, cosecant, negative, 16 minus x. Oh, these are not actually the same. Because one was x squared minus 9, the other one was whatever minus x squared. So they're not actually the same. So like, so there's still the possibility that it's right. Basically, they're not definitely wrong. All right, I'm gonna check them on the calculator. If you've been with me the whole time, awesome. If you are, I don't know, just jumping around, like, good for you, honestly. Like, you don't need to watch me solve all these if you know what you're doing. Integral of 1 over x squared, square root of 16 minus x squared, comma x. So negative, oh, well, that's interesting. I forgot to write the 1/16 last time. Okay, but that's basically that's what I got now, as far as anyone's concerned. Integral of, so number 2, square root of x squared. Is this like the right order to do this in? Like, you know, do all the problems and then check them? Probably not. So we got the radical thing right, and then -2, and then, yeah, they just chose a different inverse trig function than we did. We chose arcsecant of x over 2. They chose arctangent, but checks out, I think. Number 3, integral 1 over square root of 4x squared plus 1, comma x. Natural log thing, 1/2 thing. Yeah, we got that. And then integral, this is the one that I thought was the same. Ooh, I just got my screen time report. Ooh, it's not pretty. X for I think it was like 2 hours and 52 minutes per day, which like, that doesn't sound like a lot, except I only use this for school. So I was on my iPad that much time strictly for school. X squared, blah, 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 blah. Yeah, we got it. Okay, nice. So I did find one little error, which probably you found a long time ago. It's kind of interesting how you just never notice things if you don't like look at them from a different perspective. I forgot to put this 1/6. Well, I had it here, but then I forgot to write the 16 there. Now it's good. All right, gonna stop this here. I'll be back in the next video to do, I don't know, maybe the whole next page. We'll see. So see you there.